Hello everyone, welcome back to Linked Frequency. I am Vaibhav Sugandhi, passionate PCB designer and technology startup founder. In this video, we are going to learn about speed control of a DC motor using a Arduino Nano development board. This is the 14th tutorial of practice project for PCB designers. This tutorial is all about designing the driver circuit which will drive these kinds of DC motors in industrial application. So let's get started. First thing is black box analysis. We have an industrial application of controlling an industrial DC motor by using a driver circuit. That's why I am considering industrial DC input voltage. It may be ranging from any voltage that is available in industry, and it should be in the range of whatever the DC motor voltage recommended by the manufacturers. And then we will be having a power supply or a DC power supply unit which will convert that industrial grade DC input voltage into a suitable voltage for our main controlling unit or maybe a development board. And then for this main controlling unit, we need a USB programming circuit so that we will be programming that controller as per our requirement. In our case, it will be an Arduino Nano development board. And thereafter, we will be using a N-channel MOSFET, which is metal oxide semiconductor field effect transistor, to control on and off, also a speed control of an industrial grade DC motor. This is the very simple and very unique black box analysis with respect to the industrial DC motor speed control application. Now this is the white box analysis. Here we are declaring what are the components we are using exactly for the black box that we mentioned previously. First thing is a DC input voltage will be range of 15 volt to 24 volt, because 24 volt is most common in the industry because of PLC circuits. So that's why we will be considering this voltage range, but I am pretty sure till 35 volt you can give voltage to this entire system. Why? Because LM7812, which is a DC voltage regulator capable of handling up to 35 volt of input voltage. This LM7812 DC voltage regulator is supplying a voltage to the Arduino Nano development board as well as to our DC motor, which is of 12 volt. Again, based on the industrial application and the data sheet of that particular DC motor, we have to select which power supply to be designed at this point of time. Right now, we are considering an example of 12 volt DC motor. That's why I am considering LM7812. Again, I am assuming the current rating of this DC motor is less than 500 milliampere or maybe approximately 400 milliampere. That's why I am considering LM7812. Again, morphological chart and thorough datasheet analysis has to be done for any kind of industrial application that we are going to design in PCB industry. Arduino Nano development board is a straightforward where we will be having an inbuilt voltage regulator to convert 12 volt DC into a 5 volt. That's why we are giving a 12 volt directly to the V-in pin of the Arduino Nano development board. Hence, we will be using a USB programming circuit to program the controller, which is Atmega 328P controller inside this Arduino Nano development board to control the speed of 12 volt DC motor. To control that, we need a driver circuit, and that driver circuit we are using an N-channel MOSFET naming IRF540N, which is an N-channel 40 ampere of current handling, which is a drain current handling N-channel MOSFET, which can be used for turning on and turning off this DC motor as well as controlling the speed of a DC motor based on the amount of current flowing through that particular MOSFET. So this is all about the white box analysis. Now if we go for the MOSFET driver circuit, understanding how exactly MOSFET driver circuit looks like, this is how it looks like. First thing is we need to have one freewheeling diode along with our motor, which is a DC motor, to avoid the current recurrings or current loopings. Along with that, we will be having a 1 nanofarad ceramic capacitor to avoid the humming effect of this DC motor. The process of designing the speed controller for the DC motor will be a very complex one. Why? Because it is an inductive load, not normal resistive load. That's why there are a lot of theories you must understand how to deal with the inductive load in the control segment of the electronics industry. However, for this particular tutorial, you must understand that this ceramic capacitor, which is C3 shown here, is responsible for reducing the humming effect or a noise generated by this DC motor, whereas the freewheeling diode is used for avoiding the looping effect of the current in this particular circuit. Ignore the voltage that is mentioned here, 4.8 volt. This is a circuit taken from the internet directly, so I'm just not going to change this one at this point of time. But do remember, we are giving a 12 volt DC directly because our motor is 12 volt DC. DC. Then we will be having a one MOSFET here, which will be a N-side MOSFET or a N-channel MOSFET, because of which it is located at the low side of the entire circuit, where it will be having a one gate to source resistance, which will be helpful for locking the voltage after discharging the gate voltage, or to discharge the gate voltage after removing the PWM signal. And then we will be having a gate resistor to control the current flowing to this particular gate pin, so that it will be turned on and turned off very mathematically. This particular pin is connected to the PWM pin of our Arduino Nano development board, so that we can control the speed of this DC motor based on the pulse width and a space width of the PWM signal. It's all about the matter of duty cycle. If you control the duty cycle in a proper way based on the calculation, you can control the depletion region or the current flowing through this particular MOSFET, because of which you can control the speed of this DC motor. This is all about the basics of this driver circuit, or a MOSFET as a driver circuit. Now let's jump into the EasyEDA and start designing the circuit. Alright, we are on the EasyEDA tool. Now I will go to the file and create a new project and name it as a speed control of DC motor, or maybe whatever good name you can suit for. Now we will start with the designing this particular circuit, as we always do, with a fast forward way. Let's get started. Alright, this is how our final schematic looks like. It has any voltage, industrial grade voltage input connector, where we will be connecting an industrial grade DC voltage, and we are adding a small diode here so that we can protect our entire circuit from the reverse polarity collection. And then we will be having a capacitor filter, and then 12 volt DC power supply, which is a regulator IC 7812. Thereafter output capacitor filter and a LED indicator to indicate whether the power is coming or not. And then we will be having a 12 volt DC output. That 12 volt DC output is given to the motor. This is a motor connector. That is the place where we connect our motor, a positive pin and a negative pin. And then we have a MOSFET here, and we have our Arduino Nano with a 12 volt DC input. Again, we will be connecting a PWM pin to our gate pin, gate resistance, so that we can control it however we want it as a speed control of DC motor. So this is all about the schematic diagram. Now let's jump into the PCB layout design engineering. Alright, now you can see that the entire PCB designing is completed. Here we have mentioned almost everywhere what are the voltages or what are the connectors are meant for. In fact, here you can see that V-in and ground is mentioned with the voltage range, as well as we can see that motor plus and motor minus is also mentioned to the P2 connector with a DC motor indicating. The most important thing is we need to add a heat sink to the regulator IC as well as heat sink to the MOSFET. And most important part is the heat sink for this one should not collide with the heat sink of this one, because there is a possibility that the voltage difference may occur and may damage the entire circuit. That's why the heat sink of this one should be different and heat sink for regulator IC must be different. That's why I have created this little bit of area with the top silk layer using a track tool here to create a box or a rectangular indicating a heat sink area. And you can notice we have not given one more hole here. Why? Because our Arduino Nano need to be placed here only. As per this particular design, I felt this is the right place for the Arduino Nano, and because of that there is no possibility to give a mounting hole for that. In case of such situations, if you are giving a 3 mounting holes for the 3 corner, you can ignore one corner if it is not having a lot of vibration or a lot of mechanical imbalance. If it is basic circuit like this one, which is normal DC motor controller, and a DC motor will be sitting outside and there is no vibration inside this entire PCB, and there are no components which are related to the behavior changes because of vibration. On such cases, 3 mounting holes are sufficient for that. And if you are having a good space, then obviously give a 4th mounting hole. If not, then 3 mounting hole is sufficient. And if we go to the 2D visualization, this is how the PCB looks like top side, and this is how it looks like on the bottom side. And if you go to the 3D visualization, this is how the entire circuit looks like. This is the input point and this is the output point, and we have our USB exposed on the edge of the PCB so that you can program this entire product however you want it. And you can notice that the transistor and the regulator ICs are having a good space in between. This space is called isolation, by the way, and this isolation is sufficient for the heat sink as well. There are one bulk capacitor and another bulk capacitor at the output of this regulator. This is all about our DC motor controller circuit or DC motor speed control using Arduino Nano circuit. I hope you understood the concept of using the MOSFET as a driver in this particular tutorial, and I believe that you have learned a skill of designing a DC motor controller or a speed control of a DC motor using any development board, but this case we have taken Arduino Nano as an example, and it is nothing but designing the DC motor that are available in the market. I hope you learned and understood the concept of using a MOSFET as a driver. Thank you so much for watching this tutorial, guys. I hope you enjoyed, and consider subscribing to our channel Linked Frequency. Support us sharing this video with the people who may need it. Leave your comment if you have any question for this particular tutorial. Happy to answer your questions at any point of time. Thank you so much. See you again in the next video. Until then, tune yourself to make a difference.